Google Classroom, they remove such function, or is it my computer? There's something that uh, the settings that I've changed. I'm not so sure why. Well, anyhow, yeah, I'm showing my screen now. Let me show the slide. We have discussed this, yes. Example 17. Have we discussed this one?
Mm,
Did you?
not sure.
Yes? Not sure. Huh? You're not sure? Because I did record and it was slide number 30, which is the next one. Yeah, I think we should start at slide number 30, which is the next slide. Yeah, I'll show from that and I'll continue from that area. So I would have to record our session. But before we're going to start, is there any question that you guys would like to ask?
No.
No, so far okay, yeah. And yeah, tomorrow is our tutorial session, and since tomorrow, I've already identified the tutorial questions we're going to do, but I'm going to discuss with you guys whether you would be willing to do a lot, because there's a lot of question, and I want to ask whether you guys have a lot of assignment going on. Have you started getting your assignments?
Yeah.
Yeah.
Yeah. Okay. Then I will reduce the number of questions asking you to do. But those are good questions, especially in tutorial 4, the remainder of tutorial 4. We still have tutorial 5 concerning chapter 3. Tutorial 5 is in reference to chapter 3 as well, but we'll do it step by step. Yeah. Yeah. And what else I wanted to say? Um, week 5. So we're not midterm yet. Midterm would be somewhere week 7. So I hope all of you had a good Chinese New Year celebration and ready to study. So are you all ready?
I am.
Yeah.
Yeah.
We have a lot of slides to cover today, so I hope I can finish it, because my plan is to finish all the 30 plus slides today. If you're not able to finish it, then I might have to use our tutorial session tomorrow just to complete the syllabus. I mean, just to complete the topic on chapter 3. All right. So let me not waste any more time. I thought I'm the first one here. Why cannot I record it? Oh, man.
So we exit.
Yeah, yeah, please. Can you all exit first and then come back again?
Okay.
Thank you. Okay, welcome back everyone. So only left is Calvin. Is Calvin here also? Not yet. So I hope he will join very soon. Yeah, I'm sorry about that because let me try again one more time if I can just share the window. I can, and if I go slideshow, in my PC it does show that it is a slideshow. It's a bit late, but on the shared Google Meet, it doesn't show a slideshow. Yeah, confirm already. It doesn't, so I have to show the whole screen in order to do the session. Okay, are we still waiting for Calvin? He's not here yet?
Wait, I think he's in the previous one.
Previous one. Oh, but he should notice it because everybody has left. Oh, there he is. Hello, Calvin. You got lost, is it, to come here? Okay, I've shared my screen now. Yeah, and let me go to the slide. Before that, let me start the recording so we can start our session. Yeah. Okay, good morning, everyone. This is week 5. Today is the 15th of February, 2021. And we are in our Google Meet class for the subject Probability and Statistics BAMS 1613. Yeah. Right, so continuing to our chapter 3, the topic is probability, and we're continuing with the example 18. To my record, I remember recording to start. I recorded on my documentation that we to start slide number 30 today. So this is slide number 30, another example. It must have been we do not have enough time to cover this because normally I wouldn't stop a session in the middle of examples. Yeah, perhaps last week we ran out of time, so that's why I stopped at this particular slide. So let's continue on with this example 18. So if like any one of you have any questions whatsoever, something that I explained that you think you need further explanation, do not be shy to just turn on your mic and ask, yeah? And we can discuss on the solution. Or the another option is to type, but as you know, it takes time for me to refer back to the chat side to read the chat. Well, anyhow, in order to solve example 18, you can see there is a Venn diagram drawn. This Venn diagram is to help us to understand how the solution is to be worked out. Yeah, I've explained about conditional probability. Yeah, concerning with the given symbol, as you can see where my arrow is pointing now. That means we want to find probability of G given H has occurred. Two different events of which we want to find probability of G actually, provided the event H has happened. So there's a few information provided to us. Probability of G is equal to 0.5. Probability of H is equal to 0.4, and probability of G and H is equal to 0.1. So that is portrayed in this Venn diagram as what you can see. And because probability of G is 0.5 And we have 0.1, that is an area that is shared by both G and H. Therefore, the value here that is enclosing only G is 0.4, and same applies to H. As you can see, probability of H is 0.4, but because of the shared area here 0.1, that's why it's 0.3 on the area enclosed for H only. And as you know, the total area of probability is equal to 1, and hence 0.4 plus 0.1 plus 0.3 is in the total of 0.8, and that's why we can conclude that outside is only 0.2. So I hope you understand the Venn diagram in terms of how do we get 0.2, how do we get the value 0.4, and how do we get 0.3 for G and H respectively. So in order to answer the first part, probability of G given H, probability of the event G given H has happened, we have to use what we call as conditional probability, and that is given by this formula. So as I mentioned to you last time in our previous class, if we want to find probability of G given H, that means the numerator, as you can see where my pointer is, we find the intersection between G and H, first of all, and then divide by the denominator, which is obtained from the given value. Yeah, so that should be your guideline in order to derive what we call this, or what I call it as conditional probability. Yeah, all this while. That's the term used to define this particular question. Therefore, the information that we want are all available from the given information, like probability of G and H is 0.1 and probability of H is 0.4. So we just need to put all the values in, and that would give us 0.25. Same thing would apply to this one. Yeah, the second question, probability of H given G. So you can see it's just the opposite of each other, but well, of course, when we write the conditional probability, what do you think it will be? Anybody? Hello?
0.1 at the top.
Oh, you mean you already calculated the answer, is it, Noel?
No, not yet.
Oh, I was thinking of, yeah, what do you write in terms of the formula? So it should be probability of, the numerator should be H intersect G, because H first and then the G. What should the denominator be?
G.
Yes, probability of G. So this is how we should write it. So even though quite a few students, they written the value incorrectly, especially the denominator part. So that is where you need to be very careful what the question is asking. Now you can also see probability of H intersect with G, or also pronounced as probability of H and G, is the same as probability of G and H. Well, practically it's the same, even though you swap the position, G and H or H and G, it's still referring to where my pointer is, and the value is 0.1. But the denominator is based on the given value, which is a G. So probability of G is 0.5. So we have 0.1 divide 0.5, and that's how we get 0.2 as the answer. Okay, now the third one is probability of not H. So for probability of not H, this one you need to be aware we have probability of H, which is equal to 0.4, and therefore this is practically 1 over 4 probability of H given G. So 1 over 4 is 1 over 4. 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 So 1 over 4 is 1 over the total value 1 minus with the probability of H, which is 0.4, and that gives us 0.6. So this is something that you need to be very careful about, because it's enclosing 0.4 here and all the area outside here. Yeah. Yeah. So that was a simple formula concerning with conditional probability. Then we go on to the addition rule, which is finding probability of G or H. Now, or is the same meaning as union. That means I want to find out all this area inside the bracket. So that is why, remember when I first started explaining about probability, we have the addition rule, and for finding or G or H or union, that is, this is the formula that we use. Yeah, probability of G plus probability of H minus probability of G and H. So all the values were already given in the question. So we just have to place it in 0.5 plus 0.4 as given here, minus with the intersection of probability of G and H, and that gives us 0.8, which is, if you look diagrammatically, it is correct. We have 0.4 plus 0.1 plus 0.3, and all of that gives us 0.8 as well. Now, slightly different question in part 5 though. We want to find probability of G or not H. So if we apply the same formula, you should notice that probability of G plus probability of not H, because based on what we have here, minus probability of G not probability of G and not H. So we know probability of G is 0.5. We know probability of not H, as was obtained in question part 3, 0.6. Now the question is about this, probability of G and not H. So here, how do we get 0.4 is based on the area. You can see from the diagram, it's probability of G. We know probability of G is all this area. Just, drawing it to show probability of G. That's to show the area for probability of G. And then probability of not H, yeah, is referring to H, and not H is everything outside of H. So you can say it's everything outside, but not H. Yeah, so that means the only area enclosed is this area, which is the area 0.4. So that's why we get the value 0.4 here. Do you understand?
Okay.
Yeah.
Yeah, so that's why 0.5 plus 0.6 minus 0.4, and that is how you get 0.7. Yeah. All right, so I hope everyone is clear about that. This is just a simple example to ensure that you understand the concept of it, and using the Venn diagram would help you to solve it much better. And are the events G and H mutually exclusive? Now, especially for question that is asking for mutually exclusive and independent, to answer this, yeah, we need to use this formula, probability of G union H, or you can also say it as probability of G or H is equal to probability of G plus with probability of H. So this is the formula that we use to explain that they are mutually exclusive. So they must be equal. But if you check out the answer that we have obtained earlier, probability of G or H is 0.8. And when you add probability of G plus with probability of H, it is equal to 0.9. So you see 0.8 and 0.9, they are not equal, and hence we can conclude they are not mutually exclusive. Oops, I didn't answer about independent here, did I? So independent is, in a way, you can explain the addition rule. Let me get my pen. Or you could use probability of G given H must be equal to probability of G. They must be equal. Then they are independent. So we use this to prove. So we have obtained probability of G given H is 0.25 and probability of G is 0.5. They are not equal. So therefore, they are not independent as well. Okay. I didn't show it in this slide, did I? Oh, never mind. Is that clear, class? Any question?
No.
No question. All are okay, yeah, so far? Right, so if there is no question, we move on to the next example. Now, this example is concerning of grapefruit, and this grapefruit, it's categorized to 10% pink seedless, 20% white seedless, 30% pink with seeds, and 40% white with seeds. So you see there are two different events here. One is the concerning with seedless, and one is concerning with the color. We have pink and white. Yeah. So there are several things that is being asked here. Yeah, whether it is seedless, pink, and so forth. So this kind of question, yeah, on all the information provided here, it would be best to draw what we call it as contingency table. So this is a contingency table, as you can see, because based on the information that we have pink and white. So we have categorized pink and white here, and also seed with seed and without seeds. So you can see from the information given earlier, 10% of the pink are seedless, and that means 30% of the pink are with seeds. So that's why we get the 10% and the 30%. And 40% are with seeds, yeah, white color, and 20% white also, we are seedless. So once we have derived this table, as you can see, this is called a contingency table, and we derive it from the information that was provided. Okay, so what we got is 30% plus 40%, you get 70% for the seeds. Seedless would be 10% plus 20%, that would give us 30%. And when you total this up, you get 100%. So same thing, there are pink 40% and there are white 60%. And again, when you add these two, it will be 100%. So the 100% is our grand total. That is our grand total, okay? And apparently you can conclude here that there are 40% pink and 60% white, yeah? And seedless, there are 70% and seed with seed are 70% and without seeds are 30%. So the first question is asking, what is the probability that it is seedless? Now, how do we get the answer? Is looking at this row, seedless, and there are 30% out of 100. So in order to answer here, it is pretty much just 30%. Why? Because even though if you write it out, I'm trying to get my red pen, it is basically 30% divided by 100%. Yeah, that means probability of the value 30%, divide by the 100%, and that's how we get the 0.3. Yeah, and concerning with the pink, same case. Pink is you have 40% of the grapefruit are pink, so 40% of 100%, that would give us 0.4. Is that clear so far, class?
Right.
Yeah.
Yeah.
And then we have pink, given that it is seedless. So what this question is asking is, I want to find the probability it is pink given that it is seedless. So say I label seedless as S bar. That means, based on what we have learned, probability of pink, sorry, let's need time to do this because I'm using mouse. Remember, the numerator is pink intersect with the seedless over probability of seedless. So that gives us, yeah, just like what I've written here, similar. That means probability of pink and seedless would be 10%. So if you write it thoroughly, it's 10 over 100 divided by probability of seedless is 30, because total seedless is 30 over 100. So what we get, therefore, if you solve this, is again 0.33, or rather the 10 over 30, or 1 over 3. Okay, so I hope that is clear. Same thing with part D, seedless, given that it is pink. So the other way around. So of course our symbol would be the other way around. And as you can see here, seedless and pink, it's still 10 over 100. And probability of pink only is 40. So that's why it's 10 over 40. And our answer is 0.25. So the point is, class, you have to read the question carefully, identify what is the probability that we want and what is the given value, what is the condition stated in the question. So you might see, okay, it both involve pink and seedless. Same thing here, seedless and pink. But remember, the given for the part C is seedless. For the part D, the given is the pink. Yeah, so is that clear? Any question on this particular example? Did I? Okay, is it?
Okay.
Yeah, so I hope I did explain clearly. Like I said, if you have any question, please ask. Yeah, but these examples are quite straightforward, and do expect this kind of question in your exam. Yeah, in your assessment also. Something similar. Of course, the experiment is about something different, but the format of the question is always the same format. That means the question would ask, first, the first variable, in this case, the seedless and the pink, and then the question will continue on asking about given condition. Okay, so I hope all of you are familiar. In fact, our tutorial would be similar type of question as well. Right, so I have another example here. As you can see, the total is already calculated. Yeah, these are the total. The most important is basically male, female, enjoy shopping or not. Yeah, so yes, enjoy shopping. No means do not enjoy shopping. And we have male and female. And as you can see, the total is simply adding all the values. It's not in percentage. it's in terms of numbers. So 138 plus 222, we get 360. And same thing for no, we get 140. And when you add them, you get the grand total of 500. Now, the first question is asking, suppose the respondent is a female. Yeah, what is the probability that she enjoys shopping for clothing? Yeah, and then part B, suppose the respondent chosen does not enjoy shopping for clothing. What is the probability that the individual is a male? So you see, there is a given case here. We have female as the given condition. And what is the probability that we want? We want to know the probability that enjoys shopping for clothing. Yeah, but the given is focusing on the female, whereby on part B, we want to find out the probability that the person is a male and does not enjoy shopping. Yeah, and part C is simply to construct the probability tree. So let's look at the solution here based on the contingency table that has been provided. We want to find out the respondent is a female. So basically, we want to find out the probability that she enjoys shopping for clothing. So that means probability of yes, given that the person is a female. So based on the conditional probability is Y and female, yes and female is our numerator formula, and the denominator is based on what is given, and the given is female. All right, so checking out from the contingency table, what value do you think Y and F? What is the value we're looking at? Y and F.
222.
Yes.
222.
Yes, correct. So that means 222 over 500. So remember the it's written probability here. So you should be writing 222 over 500. And probability of female, what's the value?
256.
Yes.
Yeah, 256.
Yes, it's the value of the total of female, which is 256. So you just divide it, 256 over 500, which is the grand total, and just put it into the formula. Now, some students, they don't write the over 500. For me, I'm still okay. I still accept the answer. But when it goes to the moderator, you see, moderator is a different person entirely, and by right it should be written as this to show your working, right? But if you write 222 over 256, I still accept it, assuming that you straight away write it like you skip this particular part. Yeah, it's still okay. But the correct version of writing this would be to show this. Yeah, but if you finally write your answer like this, it's also acceptable. I have no problem with that. Okay, right? So same thing for the next one. Does not enjoy shopping for clothing. That means we looking at this part, no. Yeah, and basically male, because that's what we want to find. What is the probability that the individual is a male and does not enjoy shopping? So we have probability of M and N over probability of N. So Calvin, I haven't heard from you. What do you think the value is probability of M and N? Which one is it?
106.
Yes, so that again, 106 over 500, and probability of no is the 140 over 500. Yeah, so if you simplify it, of course, you get 106 over 140. Oops, I didn't write it in terms of decimal.
Can
So
I can I use
huh?
n? Can I use n and then bracket m intersect n instead of p? Can I just write small letter n instead of p?
instead of P, you mean this P?
Yeah, I write small letter n and then I just write a number instead of probability.
Oh, this is the actual way of writing it, because in order to get the answer is in this manner in terms of the formula. Yeah, it's still, you need to write the probability of m and n. Some students, they don't show this in the answer. Yeah, they straight away go and write the answer. But marking scheme, yeah, if I remember the marking scheme, there is a mark allocated to this formula, meaning it is in a way based on the marking scheme, students should know to write this. So I would not take the risk of not writing this down. You may lose marks. Yeah. What I observe is student no need to write this part lah. This whereby you have 106 over 500 divided by 140 over 500. But this part, the formula for this part, there is a mark allocated to it. So being a Tarshan, I mean, we are very compliant to the marking scheme. I guess we have to do that because we are marking based on 6 branches. Not all branches offer this course, and those branches that offer this course, we do have pre-marking meeting to discuss. Yeah, and what I've experienced before, writing this down is important, and there is marks allocated, and it is important to write this. So if you're saying you use, you don't write the P, is it? You straight away just write m and n over n, is it? Yeah, can we?
Okay.
So it would be, the best is to write it proper lah. Yeah. Because yeah, I guess that is required for degree students. Yeah, diploma a bit lenient, I think. So the third part of the probability, the third part of the question is to construct a probability tree diagram. So based on the information that we have, we know the first is the male and female. Yeah, which if you calculate, you get these 2 values, and yes or no. Yeah, based on the information that we have. So all these are the values for the probability tree. And these are the joint probability. That means you combine from m and y, m and n, and all these are the values of the joint probability, of course. All right, so moving on. Any question?
No.
No.
Oh yeah, importantly to take note that every time when you construct a probability tree diagram, based on the branches that you get, it should be the total value of all the probability is equal to 1. Okay, right. From here, we have A1, A2 up to AN are known as exhaustive events if the union of all the events will give us the sample space, which is the value of 1. That is what it means here, that all the exhaustive events, all these are considered as exhaustive events. You know, combine all of it, the union of all of it should be equal to the sample space, which is the value of 1. As you know, sample space is referring to all the total value, which is as you know, in probability, total value is equal to 1. So with that, we go on to a next area, which is called the Bayes' theorem. And to understand this, we have example 21. And as you can see, we have 3 persons, Alice, Barbara, and Kathy. And Alice, she packs 55%, Barbara 30%, and Kathy 15%. And then the packets that has been packed, the biscuits, apparently Alice, she broke 0.7%. Barbara is 0.2 and Kathy is 0.1 respectively. And the question is, what is the probability that a packet with broken biscuits was packed by Alice? Yeah, so our focus is Alice, given that she packed broken biscuits. So in order to solve this, a good way is using a probability tree. And if you remember the previous example, we use Venn diagram to help us to solve the probability question. We also did another example using contingency table. So now we are using probability tree to solve the problem. So based on the information that was given to us, we have Alice, Barbara, and Kathy. Each one of them give us 0.55. The amount packed by Alice. Barbara is 0.3 and Kathy 0.15. And you can see when you add all this, it will give you the value of 1. Yeah. And from Alice, 70% are broken. That means 0.3 are not. Yeah. Same thing for Barbara and Kathy. So always remember that the branches are equal to 1. Each, it starts from 1 point. If you add the 2 branches or 3 branches, or depending on how many branches it has, when you add them up, it's equal to 1. So same thing for B. If here is 0.2, the value here would be 0.8. And for C, 0.1, then the value below here should be 0.9. Now, how do we solve this? Now, remember the question is asking, all these are the joint probabilities. Excuse me. Sorry, suddenly I felt the urge to sneeze, so it was a good feeling after sneezing. Right, so what we have is, what I've listed, what you see here are all the probability, the joint probability of 0.55 times 0.70. Yeah, so you can see each branches, it has its joint probabilities. Now the question is asking, what is the probability of Alice given that it is broken? So based on what we've learned before, conditional probability, right? That means the numerator is probability of A and D, as you see here, and the denominator is based on the given value, right? Now it's very easy to identify. A and D is this, A and D, 0.385. So that would be the value up here. But the denominator, probability of D, is that we have to refer to each value that ends with a D. So we have 1 here, 1 here, and 1 here. That means we have to add this value, and this value. So in order to solve it, we have 0.385 for the value of the numerator. And for the value of D is that we have to add all these values, 0.385, 0.060, and then 0.015. So when you add all of that, that will give us 0.385 divided by 0.460. And our answer is therefore 0.8370. Is that clear? Any question?
No.
No.
Clear? Okay. So if it's clear, that's good. Okay, moving on to the next example. So this is slightly different. We have 25% of the boys and 10% of the girls are studying statistics. And from this college, 60% are girls. So that gives us only how many percent are boys? Only 40%. So the question is, if a student is selected at random and she is studying statistics, determine the probability that the student is a girl. Yeah, so what we want to find out, yeah, what probability should we be writing? I mean, what is probability of given? What is the given value? And what is it that we want to find out?
G over S.
Yeah, that means we want to find out probability of girl given that he or she is studying statistics. Yeah, so this is the probability tree, you know, just to illustrate or to help us to understand the question better. So we know 60% are girls, so that means boys are only 40%. Yeah, and from the girls, yeah, only 10% studying statistics. And for the boys, only 25% are studying statistics. So 90% of the girls are not studying statistics, and 75% of the boys are not studying statistics. So in this case, since I want to find out probability of girl given S, that means probability of girl and S as our numerator, our denominator is following the given value. Yeah, so probability of G and S, it's quite straightforward. You can get it from here, G and S. That means 0.6 times 0.1. But what about probability of S? Probability of S is given by adding this and this that ends with S. So that means 0.6 times 0.1 comes from probability of G and S, and the denominator probability of S is as long as it ends with statistics, be it a girl or a boy, you add it to represent probability of S, to indicate all the probability of statistics. So that's why we get 0.6 times 0.1 and plus with 0.4 times 0.25. And when you work out the answer, you should get 0.375. Is that clear, class?
Oh, yeah.
Yeah?
Okay.
No problem? Yes? Okay. I hope that is clear. And that's the end of that particular part. So I think that's a good place to have a break. Yeah, it's 9:52, so almost 1 hour, right? So can we continue at 10 a.m.?
Okay.
Okay,
Okay.
we have a short break. Okay. Oh, I thought it's only 10, but it's already 10:05. Are you all back? Are you
I
all
am.
back?
Yeah.
Okay, so we continue with the next area. This is called the arrangement under the small area permutation and combination. Yeah. So it is still under the topic of probability, but the idea here is that we are not um, looking at the answer we're getting as between 0 to 1, meaning the answer that you get in terms of probability, minimum 0 and maximum 1, but more into when we look at arrangement is we are counting how many ways can we arrange or rather how many arrangements that can be made based on the given situation, based on the given experiment. So it's basically a counting process in such that, say, we have n steps in which the first step can be done in k1 ways, the second step is in k2 ways, and it continues until n steps in kn ways, then the number of ways of performing the operation are simply multiplying all the ways. That means k1 times k2, and you multiply until kn, depending on how many steps that you have. Yeah, so it's just a process of counting. But it's just that based on the condition given to us, based on the constraints that is given, then we have to find out how many arrangement that is available or that we can access, right? So this is a simple example. Yeah. If, say, a travel agency, it offers special weekend trips to 7 different cities by air, rail, or bus, in how many ways can such trip be arranged? So in this particular example, take note, yeah, 7 different cities, and you have 3 choices, either by aeroplane, by the train, or by the bus. So in this case, 7 cities to select and 3 transportation types. So what we have is 7, because you can choose 7 cities. After you have chosen one of the cities, there's only 6 more left to choose from. And after you have chosen 2, yeah, 2 of them, they only have 5 to choose from. So how many ways can such trip be arranged is simply multiplying 7 times 6 times 5, and that gives us 210 ways. So you will definitely notice here now that our answer is not a probability value anymore. It is concerning with how many ways. Yeah, how many ways can you arrange? Now, some of you might be thinking that you should focus in terms of air, rail, and bus. That means only 3 choices. But remember that the cities, we have 7 different cities to choose from. Yeah, because in all the 7 cities, you can choose whichever mode of transportation. Yeah. Some cities you can go by train, and some cities you can go by bus. aeroplane is definitely yes, but only for rails and bus. Some cities can be traveled within. Yeah, like for us, if we want to go to Thailand, we can still use the bus, right? But if we want to go to Europe, it's a definite that we must use the air. Yeah. So for this example, basically, how many ways can such a trip be arranged is focusing on the 7 cities, not the transportation. Is that clear, class? Any question?
So different city use different transportation.
Oh, it's not a focus of the transportation here, Noel. It's more on the selection of how many ways can you arrange a trip, because this special weekend trip is to 7 different places. So it's not a focus on the mode of transportation, it's a focus on the places where you can go. And there are 7 cities you can choose from. So let's say you have 7 cities that you can choose from. So if you have chosen one, say you want to go to Japan, to Tokyo, for example, then the first choice you have, you got 7. Then the second choice, because you want to go to, hang on, oh, I forgot to mention this. Maybe I didn't say it correctly. You have 7 different cities, but you only have 3 modes of transportation. The question is a bit, blurry. The 3 mode of transportation, you have air, rail, or bus. Each of the cities, you can either travel air, rail, or bus, only 3. So that's why you have 7. You can choose one, and then another one, 6, because you already chosen one city. So there's only 6. And another one is, you only have 5 cities to choose from. Did I make myself clear, Noel?
No, I think I get it.
You get it or not? Maybe I didn't focus on the air, rail, or bus just now. There are 7 different cities, of course, correct. But at the same time, we have 3 transportation types to choose from. So that means the first city must be by air, second by rail, or third, and then the third one is by bus. That must be considered as well. So that's why we only have 210 ways to travel. Okay. Okay. I have to say this question is a bit blurry. I should change the question for future reference later on. Hang on, let me jot that down so that I won't forget it. Give me a minute. I need to adjust example 1. As you age, yeah, like what I'm experiencing now, I have to record everything. If not, I tend to forget. Yeah. Now we go on to the next example. Now this one, I think this is more clearer. You see, we want to make 3-digit numbers, and we have the selection from the number 2, number 3, number 4, number 5, and number 6. So our selection are only these 1, 2, 3, 4, 5 numbers. We can choose from only these numbers, no other numbers. Yeah. So only these numbers we can choose from, and we want 3 digits. Yeah. So you can visualize example, just as an example. I want to take the numbers 2, 3, 4. It's a 3 digits. That means 2, 3, 4. Another example, it could be 4, 5, 6. Yeah. But you see, for part A, there is a condition. The condition is how many 3-digit numbers can be made if each of the integer is only used once. That means once I've used the number 2, I cannot use it anymore. So for this part A, yeah, we know our n is 5. N is 5 is because I have 1, 2, 3, 4, 5 numbers to choose from. But you can only choose 3 digits, and ensuring that once you already use the number, you cannot repeat it, you cannot use it again. So in order to answer this, for the 3-digit numbers, at first, the first number, you can choose 5 because you have 5 numbers. But if, let's say, you have chosen 2, how many numbers left? You have 1, 2, 3, and 4. No, let me rephrase that. If you have chosen the number 2, so that means you only have 3, 4, 5, and 6. That is 4 numbers. At first you have 5, because our n is 5. But once you have chosen one number, it becomes only 3 numbers available. That is 3, 4, 5, and 6. And then you have chosen another number. You only have 4, 5, and 6. That means only 3 numbers. So therefore, for part A, for 3-digit numbers, you have 5, 4, 3. Multiply all that, you have 60 ways. Is that clear? Okay. Now the next condition given here, though, is stating that we have no restrictions on the number of times each integers can be used. So that means if you have used the number 2, you can use the number 2 again. If you have used the number 3, you can use the number 3 again. That means for part B, our n is 5. For the 3-digit numbers without restrictions, first number, you have 5 numbers to choose from. Second number, you have 5 numbers to choose from. Third number, you have 5 numbers to choose from because there is no restriction. You can use as many times each integer. Yeah, so therefore 5 times 5 times 5, we have 125 ways to arrange them. Is that clear? Okay, so this gives us, based on the counting rule, result number 1, the number of ways of arranging n unlike, that is, different objects in a line is n factorial. Now, if you check out your calculator, there is one button on your scientific calculator, which is the n factorial. Do you see it? The factorial symbol, it is, I don't know, depends on the version of your calculator. For my calculator, which is 570MSFX, it is on top of the x to the power of -1, next to the constant. So you need to press the shift button in order to use the factorial. But basically, the word or the symbol factorial, not the word, the symbol factorial simply means, say I have the number 4 factorial. It means 4 times 3 times 2 times 1. So it's equal to 24. So if you have your scientific calculator in front of you, you just have to press shift and press the number 4. Press the number 4 first, and then press shift and the factorial symbol that you'll see 4 with the factorial. Yeah, I upside down. And then when you press equal, you should get 24. Try it out. Do you have a calculator in front of you?
Yeah.
Yeah. So did you get 24?
Yeah.
Yeah. How about if 60 factorial? What do you get? Very big number, yes or no?
Yeah.
What is the value?
It's so big, it's 8.32 times 10 power 80.
Yes, that is correct. That is correct, Calvin. So this is the first result, number 1, concerning with factorial. So as you can see, if our number here is 3, yeah, so that means it start off with 3. 3 minus 1, you got 2. 3 minus 2, you get 1. And of course, 3 minus 3, you get 0. Well, we don't show it here. Yeah, so it's basically 3 times 2 times 1. If we only consider 3 factorial, which is just this part actually. Yeah. Another important thing about factorial is if you type, yeah, the number 2, 0 factorial, the answer is 1. So remember this, 0 factorial, don't think it's the same value as 0. It's not. 0 factorial is 1. So even if you use your calculator, it also gives you the value of 1. Yeah. So, yes.
Why?
Hmm?
0 factorial equal to 1.
Because this is about counting. Factorial is about counting. So we still have a number, which is the 0. So counting, it still exists, the 0. So that's why it's 1.
Oh,
Yeah. Yeah. So did you try using the calculator? 0 factorial?
well,
If you use the 0 can and factorial it, it's 1. Because it assumes the 0, you count the 0 as one number.
oh, okay.
Okay. So example 3, how many ways can we arrange the letters A, B, C, and D in a line? Yeah. So in this case, no condition is given to us. We just want to find out how many ways can the arrangement be done for the letters A, B, C, and D. So in this case, you see, you have 4 selection originally. A, B, C, and D. That means that's the first letter, 4. And then once you have chosen one out, you only have 3 more to choose from. That's why it's 3. And if you have chosen 2 out, you only have 2 more. And the last one is simply 1. So that's why in how many ways can we arrange the letters in a line? You have roughly about 24 ways. So this is assuming that no repetition is allowed. Because you only want to arrange the letters, that means you only use it once. That's why once you have chosen A, for example, you only have 3 letters to choose from. And once you have chosen 2 of them, you only have 2 more. And if you have chosen 3 of them, you only have 1 more. Yeah, so that's why 4 times 3 times 2 times 1, which gives us 24 ways. So just to highlight to everyone, we are looking at how many ways can the alphabets A, B, C, and D can be arranged. Yeah, and in this example, we are saying we only use them once. Okay. Any question, by the way?
No.
No.
It's clear, is it? Yeah. I hope so.
Ah, yeah.
It's clear for everyone? All right, moving on. So this is an example just to show you. Based on the example that was given to you, this is a listing of all of it. Yeah, so you can see there are 24 of them. So imagine if we have only 4 alphabets to arrange from, and you got 24 of them. And for 4 alphabets, we can still do it manually, but it's already, very tedious for us to do. So imagine if we use all 26 alphabets from A to Z. Can you imagine how big it is? Yeah, it will be 26 factorial. Whoa, it will be 4.0329 to the power of 26. So imagine that it's a very big arrangement. There's so many selection to do from, and that is why cases like this, we need computers, calculators to help us to calculate it. Yeah, our human mind is incapable of listing all the arrangement. Yeah, but computer can do so. Yeah, as long as you write a good program that allows you to do that. Okay, so this brings us to the second result, which, the number of ways of arranging in a line n objects of which P is of the same type, Q is a second type that is the same, and R the third type that is the same. Now, because in the first result that we did here, let me get back. Yeah, this is under the assumption that each of the objects are different. Like in this example here, each of the alphabets are different. But when we go to result number 2, what it is saying is that perhaps in the items given to us, some of it are the same. So for this, looking at this example, the word statistics. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters altogether. That means our N is 10. Okay, but if you look at the word statistics, some of the letters are the same. For example, the letter S, the letter T, the letter I, they are the same. So in this case, total number of arrangement, our N is 10 factorial, and this is 3 factorial because of the S, 3 factorial because of the T, and 2 factorial because of the I. The rest of the letters, they are appearing just once, like the A and the C. They are appearing only once. And because of that, the ones that are the same, because you see, let's say I take a very simple word, lily, for example, the flower lily. So if this is L number 1, this is L number 2, will it be a different if I have L, L2, I, Y, and compare to L2, L1, I, and Y? They are the same, yes or not? It's still LLIY. The second one is LLIY also. So in order not to, to consider them as 2 separate entities, they are basically the same. They are LIL, they are LLIY. So therefore we need to divide it accordingly. Yeah. So from here, we get 50,400 ways. So any cases where it has similar letters, yeah, you need to divide by its factorial depending on how many that is the same. Is that clear?
Okay.
Yeah. Now looking at example 5, slightly different scenario. We have 5 red balls, 2 white balls, and 3 blue balls. So 3 colors are at play. All are balls, yeah, the same. We have red, white, and blue. And they are arranged in a row. And how many ways can the balls be arranged? So in this case, it doesn't matter. It matters about the color, but if you have the red balls, if you position red, 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 yeah, because there are 5 red balls, right? So in a way, they are considered the same, just like the letters. So for this, you have 5, 2, and 3. Again, there are 10, but 5 are red, 2 are white, and 3 are blue. So this refers to the red and to the white and the blue. So red, there are 5, that's why it's 5 factorial. The white, there are 2, and the blue, there are 3. So this will give us only 2,520. Is that clear? Any questions?
No.
Okay, moving on. Okay, now just now was the counting rule, or rather concerning with how many items given to you, and in order to list out how many ways can we arrange them. And we have looked at if each of the item are different, and cases where some of the items they are the same. So based on that knowledge, you see it's a different way of thinking already, yeah? Compared to the first part of this topic, chapter 3, we look at probability, right? Now on this area, we are looking at how do we arrange or how do we count. So this comes to the second part here, which is called the permutation, is again concerning with arrangement. We want to consider how many ways we can do the arrangement for the set of objects in such that the arrangement is significant, meaning the order of the arrangement is important. That means the position is important. Say, okay, I have 2%, yeah, 2% in a group. And then from that 2%, I appoint one person to become the leader. The second person is the assistant. So in this case, the first person is the leader. The order is important. Yeah. So you can only choose number 1 as the leader, number 2 as the assistant. So in terms of permutation, order is important. So the formula is for the permutation of n different objects. Yeah, say I have n, depending on how many n you have, the number of arrangements of R objects. R here is the number that you want to choose from n unlike objects is given by this formula NPR, n permutes R equals to n factorial over n minus R factorial. Yeah, that means if you have, say, 8n, your n is 8, That means you can choose from 8 different objects. Permute, say you want to choose only 2, then it is 8 factorial divided by 8 minus 2 factorial. That means 8 factorial divided by 6 factorial. So you can manually calculate it lah. Yeah. However, in your scientific calculator, I'm not sure whether you have used it before. You can also calculate it. Yeah. So please, if you haven't used it before, please pay attention. How you can use it is first in your calculator, you press 8 and then you press the shift button in your calculator. Yeah, so 8, press shift, and then you press, if you look at your calculator above the multiplication, you can see the symbol NPR. Do you see that? Because you already pressed the shift. And when you press the symbol for multiplication, depending on your calculator, you should see the NPR, yeah, which is colored in brown, and then you press the number 2, and then you press the equal sign. What answer do you get? Lance, what answer did you get?
Oh, 56, I think.
Yes. Yeah, so that is how we use the calculator. There are 2 options. You can use the calculator to get the answer very quickly, or you can use the formula, of which we are using this formula, n factorial divided by n minus r factorial. So if you use the factorial symbol to calculate it, you still get the same answer, like 56. Or if you use the calculator, you would also get 56. Which one do you find easier? Use the formula or the calculator?
Calculator.
Calculator, right? Let me answer a very quick message from Miss Leah. Okay, sorry about that. There was an urgent question from Miss Lee. Right, moving on. So I hope you understand how to use the permutation. So the idea is you have to choose from n number of items and already informed to you how many objects that you want to choose from. So example, yeah, just give you a scenario, a simple one, like in a classroom, there are 30 students and you want to choose from that 30 students. You don't know who yet, but from that 30 students, you want to choose 2 persons to become your class rep. So how many ways can you choose? How many arrangement from that students, 30 students, can you choose 2 persons as your class rep? So 30 permute or 30 permutation 2, and that would be 870. Okay. Right. Moving on. I hope you understand, yeah? So let's look at an example. Oh yeah, there's one part. You can try it out. N permute n will give you n factorial. Say, if you try 2 permute 2, try it out using your calculator. So if you press 2 permute 2, you get the value equals to 2, which is 2 factorial, which is 2 also. So be careful, if 3 permute 3, What do you get?
Uh, 6.
Yeah, because it is 3 factorial. And we know 3 factorial is 3 times 2 times 1. It is 6. Okay, so need to be careful about that. All right, so these are considering with permutation. Let's look at an example. So how many ways the 2 letters from A, B, C, and D can be arranged? So you see our N, how many can we choose from? There are 4. Yeah. And how many 2 letters do we want? So it could be AB, it could be AC, it could be CD. Yeah. So total number of arrangement is 4 permutation 2. So using the formula, it is 4 factorial divide by 4 minus 2 factorial. And if you want to use the calculator, you can straight away calculate 4 permute 2. And you can also try out using the formula, and this will give you 12 ways. What are the 12 ways? They are all this. Yeah. So notice here, we already have AB, but we do not have BA. Do you understand? That means order matters, position matters, because you have 4 to choose from, A, B, C, and D, and the condition is you want to select 2. So if you've selected A and B, it's the same as B and A. So that is permutation. Permutation means order is important. Yeah, meaning you already selected AB, it's the same as BA. So that's why we only have 12. Yeah, 12 2 letters. You can see here A, B, A, C, and all this that is listed. Yeah, those are the 12 ways. So instead of, we don't have to list all of this. We can count it. We straight away know the 12 ways. So imagine if your N is, say, 60. Will you be able to list one by one of 2 letters you want to choose from N equals to 60? No, it would be very tedious. Yeah, and if you can write such a program that allow you to do this task, then it's very useful. There are areas, agencies, companies that need to have this information, like the random numbers of 2% they want to select from the N of 60. Yeah, so it's just that you need to understand the idea of permutation is concerning with selecting, yeah, how many from that N, from that group, how many R you want to select from the group, in such that the position is important, order is important. Yeah, so I hope that is clear. I hope you understand the idea of it. Yes, so far okay. Right, no question, but if you have any questions, straight away do ask me. Now the next one is example 7. If 20 students are entered in a contest, in how many different ways can a judge award a first prize and a second prize to the students? Yeah, so you see, the order is very important here. We want to award one person to get the first prize and one person to get the second prize. So our N is 20. And we want to choose only 2 students. How many different ways can we award one person as the first prize and the second person as the second prize? So NPR, order matters. So 20 permutation 2, we have 380 ways. Okay. Moving on. I hope you understand about permutation. Yes or not?
I am.
Yeah,
Okay, yeah.
can we just write the 20p2 without the calculation, and then
Oh,
just write the
yes.
answer?
You mean assuming you are using calculator straight away to get this answer, right?
Yeah.
Yeah, that means you skip this, it's okay, because calculator is allowed. Yeah, so say you don't want to write this, for this it is okay. Yeah, because it is allowed to use the calculator to calculate the value. Yeah, so based on our knowledge on permutation, we go on to the next area, which we call it as the combination. Yeah. Combination is a way of selecting several things out of a larger group, but same thing like permutation basically. But the only difference is, different than permutation is, order does not matter. Yeah. Um, yeah. Slightly still counting ways, but order, it doesn't matter now. Yeah, just now permutation, order matters, right? It's very important who's position number 1 and who's position number 2. But combination, order does not matter. Say, for example, if you already order, you go to a restaurant, right? You already ordered chicken curry and you already order chicken tofu. It's it's the same. You cannot say chicken curry and chicken tofu is different from chicken tofu and chicken curry. So combination would consider that as one, because order does not matter. Whether you order the chicken tofu first and then chicken curry, or if you order the chicken curry then chicken tofu, it's the same. Or let it be just A and B. If A, B, it's the same as BA. That's what combination is about. So same idea, we're still using R and N. The number of combination of R objects chosen from N different objects, yeah, is given by NCR equal to N factorial divide by R factorial, and in brackets N minus R factorial. So slightly different. We have an extra thing here, which is the R factorial as compared to the permutation formula. It's divided by the R factorial here. So just to show you a simple example, in how many ways 4 letters can be chosen from the word randomly. Yeah, so we have randomly here, our N, yeah, we have 1, 2, 3, 4, 5, 6, 7, and 8. Our N is 8. And since the question wants 4 letters, our R is 4. So when we put it into the combination formula, we have 8 factorial divided by 4 factorial in brackets 8 minus 4 factorial. That would give us 70 ways. So same thing, you can use your calculator. Do you see the NCR in your calculator? If you're using the same version as my calculator, FX570MS Casio calculator, you can see the NCR is above the divide symbol. Yeah, so in order to press this, we have 8 shift. You must press the shift NCR so that you see the C and 4, and you should get 70. Did you try it out? Kelvin, did you get 70 using the calculator? Kelvin.
Yeah.
Did you get 70?
Yeah.
Okay, good. How about you, Farah?
Yeah.
You got 70. And Noel? Okay, also.
Yeah.
Okay, good. I assume you have used the calculator counting this before. Yeah, so that's good. If not, just in case you never use it before, there is many ways you can, because by me explaining using my own words, it may be lacking in the explanation. So I would recommend you guys to check out from YouTube. You just need to type counting permutation using calculator. There's a lot of videos online for you to search from. Yeah, but I remember in high school you do learn about permutation and combination. Not in depth though, but I think it's taught. Well, anyhow, I hope you do. If you have problems in using the calculator to find the permutation and combination, let me know. I'll search a good video and post it in our Google Classroom if you need it. But if not, that means you're okay. So continuing on, we still have about 9 more minutes. Look at the combination example here. Say I have a committee. I want to choose 2 ladies and 3 men from 5 ladies and 7 men. So our total N is 5 plus 7. Yeah, 5 ladies and 5 men. I have 12 people altogether, but 5 are ladies and 7 are men. Yeah. Now, the committee, though, we want 2 ladies and 3 men. In how many ways can this be done if any lady and any man can be included? So there's no limit. So for this case, I can choose, well, 2 ladies, right? So from the 5, 2 are ladies, and from the men, 3 are men. So you see, 5 are the ladies, 7 are the men. So from the ladies, 2 are chosen for the committee, 7 from the men, 3 are chosen as the committee. So you need to use a calculator, the calculator of yours, to calculate this. So 5 combination 2 times 7 combination 3. Yeah, here I show the formula still, but you can use straight away using your calculator, and that would give you 10 times 35, and the answer is 350 ways. Okay, are we clear? The next question, one particular man must be in the committee. So that means one of the men is already in the committee. We don't have to choose one of the men, but the 2 ladies, we still have to choose. So for this case, yeah, since one of the men has been chosen, that means we only have 6 more men to choose from, because one of the men confirmed already in the committee. Yeah, so that means for this, the ladies, it's still 5 combination 2. You see that? But the men, because one particular man must be in the committee, we need to choose only 2 person left. And the total number we can choose from is 6. Not 7 anymore, because one of the 7 men has been confirmed chosen. So the remainder, only 6 more men inside that group, we choose only 2 more. So you see here 2 and 2. You might say it's only 4. Yes, because there should be 5 people in the committee, but 4 plus the 1 confirmed man is already in the committee. So for this same formula, you would get 10 times 15, which is 150 ways. Okay. Any question?
So far no.
Okay. And the last person, two particular ladies cannot be in the committee. So remember, ladies got 5 ladies, right? But 2 of the ladies here cannot be in the committee, so you only have 3 ladies. So from the ladies, 2 of them must be there. So that's why we have 3 combination 2, and the men 7 combination 3. Yeah. So in this case, the men we choose from the 7 men we choose 3, but the ladies 5 ladies originally, but 2 cannot be in the committee. So we only need to choose from the 3 person, 2 of them. From the 3 person, 2 of them can be in the committee, and therefore, calculating that would give us 105 ways lah. Okay.
Okay.
Okay, good. All right. Moving on. 10:56 already. Let me go and check here how many more slides we can go through. Oh, 40. Whoa, quite a lot, yeah. I might have to use our tutorial. What do you have class afterwards? I mean now 11.
11:30.
11?
30.
11:30?
Yeah.
Yeah, so I think I stop here. The rest of the example, starting from slide 50 to 64, I will do it during our tutorial tomorrow, can or not? And then I will give you less tutorial work to do. I will message you the question, Ken?
Okay.
Okay.
I think that's all for today. We'll continue tomorrow then. All right?
Okay, Miss.
All right. Thank you very much. I'll see you guys tomorrow then. And I'll WhatsApp the question for all of you to do. Okay?
Same.
Okay, Miss. Thank you.
Thank you. Bye bye.